question. Hacker SQL important questions. Today we'll be discussing symmetric pairs, and the requirement is simple. In a way that we have to find those pairs in which the x1, the x of this table, this is the x1, the first record, right? x1 20 is equal to the y2, right? And y1 will be equal to the x2. If any record is satisfying this condition, then it is considered as symmetric pair. You can see it in here as well. 23 is the x1 is equal to the y2 23, and x2 22 is equal to the y1 22. All these pairs are considered as symmetric pair. We have to find all those symmetric pair. And the main, there is two catch to this question. We'll come to this in a minute. The first and most important thing in question is how I can get this table, how I can compare, right, the first row record with the second row record. How can we compare that? To do this, we can do one thing. We can self join this table on x with y. So how can we do this? We can do this like we are first self joining this table symmetric function and self joining with itself, and we are joining it on the basis like the x of this function, x of the first table will join on the y of the second table. Basically we are joining x with the y, and y, like how it gonna help is like, consider this, like if it is like 20 will match with 20, right? So the first row will contain in this 20 20 20, like all four single line you get the 20, four 20s. For the second as well you get 4 20s. Consider this 20, then again it will check like x of this 20 will be checked with the y of this 20. So you will get like I'll just give you a quick example how this table will be formed when we join. So for the first 20, consider this for the first 20 you will get as 20 20 20 20, because we are joining 20 with this 20. So my first record, this will remain same, but it is joining with the y, so this will also remain the same 20 20. I'll give you this example like 2021 when it's joined with 20 y of 20. How it gonna look? It gonna look like this. Like for x it will be 2021, and for y my whole record is like for example y1, right? x1 is 20, but for this x3 y3 is 21, so the record will look like this. One more example, suppose we are joining 21 of x with the 21 of y, right? That's how it's gonna join, right? So how it gonna look like for x5 y5 is 20. So for x1 x value is 21, y value for relative to this x is 20, right? So this gonna go like this. Now for y, whom it is gonna join, the value of x is 20. So this is 20 and this. So this is how it's gonna look like at the end when you join this table of x with y. And now we are close to our question in a way that now we get now we can compare like x1, consider this is x1, and then you get the y1, and this will be x2, and this will be y2. Now you can easily put a case when situation, and case when statement you can compare that, like if the second thing to consider here is like this 2020, right? If it contains a single line, like for example, um, consider this 21. Now I'll show you in this table, like all these thing, all the records that is consisting of only single value, right? 86, 86. What it gonna show is it's not a symmetric pair, because for example, if 20 is being like x of this 20, right? X1 will be joining with y1 of 20, right? If it is only single record. Similarly, consider this way, x of x, like for example, I'll show you, like if my table is consisting of this 86, 8 and 8 suppose, and 9 and 9. Now if you're going to join x with y, so the resultant will be like, since x of this will be joining with y of this, right? So it will generate a single record 8, 8, 8 and 8. That's it. So this is not a symmetric pair because it is not combining with y. X1 is not combining with Y1, so like this single row is not relevant or is not considered as symmetric pair. That's why we neglect all the entries with that is having a single row. What we are focused on is, if the record is having more than one row, then it is considered, like for this 13, it has more than one line. Now we can say that yes, there might be a scenario where like 13 is like, you can say it in here, like 13 must have joined with the y of 13, then there is another 13 that has joined with it. Now this can be considered as a valid scenario, because x1 is equal to the y2 and x2 is equal to the y1. This is a symmetric pair. So for that, entry must be greater than 1. That's the only thing that need to be focused in this question. You can solve this by getting like case and suggestion, like I mentioned, and you can join like, uh, you can basically, you have to focus on two things. One is that for symmetric pair, that y1 is equal to the x2 and x1, like, because that also a case that, for example, here we have 4, then 22, 22 and then 4. This is also symmetric pair, right? So how it gonna look like is this: 4, 22, then 22 and 4. So this is symmetric pairs, right? And the only one that has the multiple entries, 13, 13, is also considered. Apart from this, the question is solved easily. That's the only thing that need to be focused. You can join, you can create the separate case for both the scenarios where my entry, if all the values are equal and has a greater than one record, then it is being considered in one table, and if my y1 is equal to the x2 and x1 is equal to y2, then it is considered in a second record.